Powerfactory 2022 is now available, and I'd like to show you some of the new features that we have developed this year. For RMS and EMT simulations, we have introduced the Modelica interface. Modelica is an open source modeling language, which enables users to implement discrete-time modeling. In Powerfactory, this is done using Modelica models. In this simple example, a sorting algorithm is run at each sample time. The input signal is a vector of size 8, and the output signal, again a vector of size 8, contains the signal values sorted in ascending order. Let us see the effect when the simulation is run. The sorted variables are shown in the lower plot. You can see that the blue curve at the bottom plots the lowest value at each sample time, and the brown curve at the top the highest values. In addition, Powerfactory now supports the Functional Mockup Interface Standard, or FMI, for the exchange of simulation models. This means that Modelica models can easily be exported as so-called FMUs, or Functional Mockup Units. It also allows the import of such models as well as models from other simulation tools. FMUs from Powerfactory or other simulation packages can be used as inputs for simulations, including co-simulations. We have introduced FMI for co-simulation, allowing users to carry out co-simulation with a wide range of external tools. Powerfactory can be used to coordinate several functional mockup units in a combined power system co-simulation with other external processes. Artificial intelligence is increasingly used for sophisticated modeling of complex systems. In Powerfactory 2022, we have introduced an AI option for quasi-dynamic simulations. The concept is that a neural network can be created and trained for a given network topology, then used in a quasi-dynamic simulation. These result in extremely good approximations obtained in a fraction of the time for a normal simulation. The first steps are to configure the low-flow command and then the required settings for the neural network. The input will be a dataset of randomized set points based on the element attribute characteristics or distributions. Output variables also need to be assigned. With this command, the dataset is created and then used to train the neural network. The probabilistic analysis function is used to create the randomized dataset, and then the network training can take place. Once the neural network has been trained, it can be used in the quasi-dynamic simulation. These plots show, for 2 lines and 2 transformers in the network, the loading profile using the standard simulation. Now the neural network option is selected and the simulation run again. With the blue lines showing the AI loadings, we can see how closely the results align. Several new features have been added to the reliability analysis functions. One of these is the new optimal recloser placement tool. This identifies optimal locations in the network for switches to act as reclosers, so as to reduce customer downtime and thereby improve reliability indices. In this example, 3 new locations are identified. The report shows the resultant improvement in the reliability indices. And the contribution of each recloser can be seen in detail. For example, we can see that using this switch as a recloser has the biggest impact on the energy not supplied, reducing it by 750 MWh per annum. Powerfactory now offers a protection coordination assistant for overcurrent as well as distance protection. This allows overcurrent settings to be automatically calculated according to user-defined rules as shown here. And here the user can enter grading times according to elements. When the command is executed, the current set points are calculated and then time grading is carried out. The tabular report allows users to view the settings, with the option to transfer the settings to the relevant devices. Last year, we introduced the Variation Manager, allowing users to see their network variations in a Gantt chart format. This has now been extended with new views and options. An Object Modifications tab shows changes in the network elements in list or hierarchy view. And it is easy to see which variations affect particular elements. In the Attribute Modifications tab, the details of the attribute changes are shown. The values can be edited, with the changes being written directly into the relevant expansion stages. Back on the Object Modifications tab, this conflicts column can be very useful if you have many complex variations to manage. Conflicts are highlighted, and the relevant variations and expansion stages can be readily accessed. These are just a few of the new features to be found in Powerfactory 2022. Many other calculation functions and data management tools have new options and enhanced functionality. There are of course also new and improved power equipment models, such as the new moving train model and the capacitor commutated converter option for the rectifier inverter and HVDC LCC models. For information about all these and much more, take a look at the What's New document.